Hey, hi everyone. Welcome to my channel. Today we are gonna have an interesting real-time GenAI application, which gonna create a for food delivery app. So you know, right? The challenges of the food delivery apps. It's gonna be how fast the food is gonna be delivered, and what is kind of like a time it's gonna take to come set. Who is driving it? The delivery ones, and those are the critical aspects of food delivery app because most of the food delivery apps is going to run to the kind of a bad jobs at this moment. But when they goes for the real time with the GenAI application, they might have challenges to have interactions to have the real time data. So Redpanda is going to give a kind of a on go solution for streaming data. So which go with the help of the WebAssembly. I've been interacted with Christian in my Rakuten stream event. It has happened so the one 2 months back. So there was interesting conversations, right? How I can build a real time GenAI applications with streaming data. There is a challenge for that, but how we are going to solve that problem with Redpanda. So I'm going to deep dive into how I'm going to do the data ingestions with help of the real time stream and how it's going to inject it into the Redpanda clusters and create those pubs of topics on top of it, and how I'm utilizing the data processing with WebAssembly and to clean and transform and enrich the real-time data. So there was challenges to do the real-time data processing. They might require a huge compute, but that can be solved by the WebAssembly itself. So we don't need to worry about to clean and transform and enrich. There's going to be a kind of like huge compute going to comes into the place, which I dealt with the most of the times. They are going to be medallion architecture where I kept the data and I have to enrich it and I have to use the compute, but that's going to do it on fly. We have some checklists which you can run on your SDKs on top of your applications, and how I'm going to model and train the machine learning on top of my historical data and then the real-time data which are coming from my real-time interfaces, and how fast I'm going to train my model and generate accurate delivery estimates. It depends upon the who is driving, what is his age, what is the bike he's going to driving it, and how fast it's going to comes it, what is the delivery time, what predictions, what routes, who is allocated to it, what could be his previous ratings, and how customer is satisfied with his deliveries time. So we have a nutshell within the app itself. We can have the real-time interactions with the agent because in the pandemic we know, right, it's gonna know, right, who is accessing. On top of it, right, we can have the real-time fraud detections and personalized recommendations with the help of the GenAI, and we can see what they order it, right, and what the lake likes it. And we can understand the demand and supply within the chain with real time monitoring into the AI ecosystem. So let's dive into the problem. Current problem is in food delivery. They are going to be, as I said, like the batch processing is going to be happening, and huge compute is going to be utilized. But with the help of the Redpanda WebAssembly, we can do it into the real time, and we can do it the massive, huge volume of the data and the speed and the accuracy. It's going to be very highly efficiency and low latency to build your GenAI applications within the pipelines to do that. So I'm going to go to show you a kind of like a demo how the GenAI application which currently we are gonna build it, and which neural network model which we are gonna do it, right, what SDKs which we are gonna do it, and how WebAssembly runs on top of into the applications, right, streaming itself on top of those topics into virtual machines, right. And I'm going to walk through the key deployments strategies, how I'm being to do high availabilities of it. So before I goes through, right, I wanted to walk through the architecture diagram. I set it up a lab for you. So I got it from, I done this lab. So let's give the architecture view, how it's going to work. There's going to be a real-time food delivery data, raw data. It's keep on injecting into the red pandas clusters, right, where we're going to process, clean, and feature the data set, right, in the broker data. So it's going to be a kind of like on the fly which we are going to do it. It's not going to do any ping pong with the using of the compute, and we use training LLMs on top of it, and we go back with the dynamic model updated and do the real time interference to the application. So let's go how it's going to happening bit, right. I'm just going to give the walkthrough of the same thing, right. So this is a traditional one, right. We are having the source of data. We are doing the data transform within the data lakehouse architectures, right? But Redpanda, we have upstream and downstream. We inject the data, we just store the data and transform on the fly, and it's gonna done. The help is right. Low latency and high throughput is the key achievements. How we are gonna do with the client side SDK tools and data transform lifecycle management and data flow with WebAssembly on runtime, right? These are the tools. It's gonna works in this way, and this is going to be a data flow through WebAssembly. There's a core one with broker one and broker B, which has a WebAssembly runtime on top of it, and the core one, and so the RAF it's going to store, and broker B it's going to have the score. It's going to done. So it's smooth in terms of it, and if you look at the architecture, and I'm going to walk through it like into the lab, right? Before going to the lab, I just wanted to give a heads up, right? So how we are going to trying to do that. So we have that import the model. We build the classes with this one, and we have a Kafka consumer, right? So within the data stream of Kafka, and we import the data, and we process it further into the data and each of the model, and then train that model data on top of it. So this is a kind of like a basic example of the code which I'm gonna try to show it out, and how I'm doing the data acquisitions, data decoding, right? So with the help of the functions, right? It takes the Kafka streams and it do the massage on top of the CSV files, and trying the entire loop with it. So this is a kind of a machine learning model, and on top of it, like how we are going to do the error handling it. So there might we are injecting the relationships between the distance and delivery the food, because that might be the kilometers and the coordinates which we need to send. There is a latitude longitude of those data which gonna pass on top of our real-time applications, which is nothing but like we're gonna add metadata on top of it. What could be the delivery person's age, what is his previous ratings and everything, right? This one, let's go and do the lab. So lab is wonderful. It's pretty kind of like I've done a couple of times. I love it. So I'm just gonna run this git clone. So before I'm gonna do it, right, you can see that from here the clone one. So whoever likes to go deeper into the code, which they can see that one. Yeah. So then I'm trying to use my Docker Compose file so to run it. So it's created my Jupyter notebook and Red Pandas one. So this is kind of like within the clusters, right? How Red Panda clusters are going to be looks like. It should be like this. There's one, two, kind of a cluster, and there can be a console, and Jupyter notebooks is going to run on top of it. And now I wanted to go back and explore the my data. So I can go to the my Jupyter notebook, right? I have the data. From here, if I go back to here, I have stats one. Like let me open it for you. So this is a data exploration which I'm talking about, like the beginning the relationship between the distance and time taken to deliver this one. So let's do it. Ignore those ones, right? It's gonna give us like what is the delivery person, and what is his age, what is his the ratings, restaurant latitude and delivery time, and then delivery locations, longitude and latitude. So these are the ones is key when you're delivering um, uh, for food delivery, to know right what type of order, what is a vehicle, and what is the time it's going to taking it. These are the historical data which we are considered at this moment, and we use this real time data on top of it, and we will going to give the better results. So I've taken the both the historical data of the person, whose age and everything, and I'm going to inject new data on top of it, right? So this is a relationship. It's going to take right the time taken in the minutes, right? The distance is covered to once. So if you look at right, so it's when it comes to the age, right? It's going to get a 49 once, right? And age 20, right? It's going to goes into the distance is like 20 minutes, and age is going to goes. It's going to be increasing in the minutes. Means like if a guy is 20 years age, is going to deliver much faster, right? And it's going to show a relationship right? The relationship between time taking and the rating, right? So it's gonna be shows you, right, that the delivery person rating is gonna be less when the time increases, right? So it's always gonna be when you order the food, if it comes late, you are not happy um, with the ones. These are the historical data. If it shows like what kind of vehicle is being there, and it's been like drinks, meals, right? And if it's like what is the duration it's going to take, it like what is the minimum and what is going to be maximum. If you look at like the minimum is going to be into it's going to be in a scooter, and it's going to be lesser compared to the motorcycle, and bicycle is much faster because this is taken by the kind of like a geographical data, if you look at, right? So how fast we are going to do it this way. So let's jump on this, right? Now you have seen it like this other historical data which I run, and I've shown that. Right now we are going to do inject the real-time data, right? So let's do the injection of the real-time data for this workshop. So I created the three kind of like ones to inject the data. Now let's see those topics how we are going to come to. So we run that, and we are creating those three topics. Is there are going to be two topics which are created in the raw and model data, and we are gonna do the produce this one. What is going to be happening, right? We are going to keep on producing this data, and we can go back and see into the topic, right? If you go back and see this topic, so I'm keep on sending the real-time data with the help of my terminal, right? It's going to keep on increasing it here with the raw data. So let me stop that. So you can see that, right? It's a kind of a real-time data which I'm getting for the vehicle numbers. What are the values which you have given? That is the time and duration to the ones. Like there is number of one. So it's highly scalable in terms of it. Like we injected that kind of a data. It's continuously one. No, I'm trying to see is right. So what we are trying to do it like we are doing the cluster creations. So on the fly, right? So we are doing this, and we are creating the Docker Compose ones. And I have given the name. The name is one, and I expected like higher throughput, right? And I'm installing the dependencies which is required to do that one. So it's just downloading the package of it, and I can see that folders, right, when I'm doing it like the transform one. The moment if I go to the editor one, if I go to the food ones, if I go to the transformer one, so I'm changing this logic. This is a WebAssembly logic, which is a key one, right? So on the go itself, how we are transforming those records by the distance, right? If it prints null values. So this is how you're taking that CSV data, and we are getting calculating the distance between the 2 points and age and reading. So this is the kind of like real-time data on the fly, which you are using it and without doing any compute or anything, right? So we just giving the command and doing with the help of the function, right? The function is gonna be closed. So what is function is gonna do it, right? It's taking that CSV data and it's converting the data. It's doing the distance calculations and it's formatting the data, and it's gonna do it. Let's just go to the terminal and build that. So we build this, right? So it inject the data and we're gonna get it, and then we are using it. Now we are gonna do it into the cluster deployment, right? So the cluster deployment is being done. So what is happening? So we have done a simulation with a kind of like a data, which is going to comes into our topics into the raw the one master. and then we have the historical data which is deployed one, and on the go we are doing that WebAssembly, so to add the additional metadata on top of it. What happening it here, like it's taking into the each ones, right? The architecture wise I've defined to you, and it's taking to each VM, and it is doing that kind of like work. Now, if you look at like if you have raw data and the model data, and there is going to be lag as well is going to be there. Now, what I'm trying to do it right, I'm trying to do the model data. So we have seen the data which seen raw data, right? Now we can see the model data. So the stimulation is going to come to the model data. It's coming. So it means like real time. I inject the data. I've done the raw data, and it's going to be once, right? It's going to send that thousand number of the rows, and where we have the deploying our MLOps pipelines on top of this data, and try to train the data on the fly itself. I'm closing it, so you can see that number of the rows. It's going to be increased here, right? The real time data. Now what we're going to do is like we're trying to see the producer, right? Which we are doing it again, and we are trying to see from the consumer model, right? We have received the data from the simulation. We done our WebAssembly. We train our MLOps model, right? And how this model is going to serving into the real time application, right? So before we go here, we have the Jupyter notebook into the consumer topics as well, right? So if you go to the consumer uh, topic here, right? We have the Kafka topics, which is coming as a consumer on top of it, which we have done it right. So let me run, right? Let me see it. It's been done. So let me go and run my. It's taking that historical data on top of it, the new data, and then it's gonna gives like the outshape, the parameters, the how many dense ones it's gonna come, and this is the pipelines which we are trying to use it, right? To do the MLOps on top of it. Now we have the real time data as well, right? So which is going to show us like the real data of this application, how fast the consumer is going to come sit taking the real time data, because we train this model and we are doing the real time interference with the applications wise. Looks like our Kafka session has been timed out. That's the reason we are getting this error message. I think they're gonna be issue, but however, it's gonna predict that model, right? And it's gonna gives you this kind of like interfere, like what is a driver's age and rating. It's gonna predict the real time milliseconds, right? How like real time prediction time it's gonna happen whenever your food is gonna deliver. So this is gonna be very real time to create this generic kind of a applications, right? To do the model ones. I think like if I'm getting this right, this kind of a error, right? I'm expecting to import uh, in the my bash one. So like let's import the number pi and the load this training data. This is kind of like a floating test we can give it with a result, and then trying this data, right? Yeah, that's about. And there is a one important one which is from Redpanda. It comes up, right? The sovereign AI, which means like your data is gonna be stay within your um, network. It's gonna be deploy on top of your local cache. Like from your data will not gonna be goes anywhere. That's a new feature. I love it, and I love the way Redpanda is been performing with this scenario. I've been done. Maybe it's not working at this moment, but it's in real time. It's very highly accurate. But that's how it's gonna come set. Like it's gonna give the real time predictions within the app itself. That's a new innovative way of like building app. Yeah, thanks for watching it, and I hope you like the content. Please subscribe.